Okay, today's lesson is on Chapter 0, Section 6, Matrix Operations. Basically, a matrix is a rectangular array of variables or constants in horizontal rows and vertical columns, usually enclosed in brackets. Each value in a matrix is called an element, and a matrix is usually named with a capital letter. Here's an example of a matrix. This particular matrix is titled capital A. It is made up of columns and rows. So matrix A has 3 rows and 4 columns, so it's a 3 by 4 matrix. This is very important right here. And you need to be able to see that and say, oh, it has 3 rows and 4 columns without looking at the matrix. You always say your rows first, then your columns. Each element in this matrix A, for example, -2, we're going to say that -2 is the value for A, but we say lowercase a, and then we put the row. Which row is it in? Well, it's in the first row. So it's in the first row. And which column is it in? It's in the first column. So we would describe the value of A11 as -2. So let's go ahead and look at this element right here. -3 is the value of an element in matrix A. In which row? The second row. In which column? The third column. And that can be a little confusing. First example, we have matrix A with the following elements. I want you to state the dimensions of A. The dimensions means the rows by the columns. So how many rows does matrix A have? It has 2 rows. So it's a 2 by, how many columns does it have? It has 3 columns. So it's a 2 by 3 matrix. Part B wants me to find the value of A13. So that's the element in matrix A that is in the first row. So it's in the first row. Excuse me, I just did a column. The first row, the third column. And the place where these two intersect is right here at -18. So the value of that is -18. Go ahead and try the following. And here is your solution. Specially named matrices. There are 4 kinds of matrices we're going to talk about. The first is a row matrix. And that is a matrix that has 1 row. It doesn't say anything about columns. It can be the example shown, or it can be 5, 4, 3, 6, 8, 9. It could be that matrix. A column matrix is a matrix that has 1 column. Just so happens that this one has 3 elements in it. It could have 20 elements in it, but they're all in 1 column. A square matrix is a matrix that has the same number of rows and columns. So the one pictured has 2 rows and 2 columns. So if the dimensions are the same, it's a square matrix. And a zero matrix is a matrix in which every element inside of it is 0. Equal matrices, that is when each element of one matrix is equal to the corresponding element in the other matrix. So corresponding refers to elements that are in the exact same position in each matrix. So in matrix A, I have element A11, first row, first column, is the value 4. So the element in the same position, here's the position, row 1, column 1, would be this. What's corresponding to 2? 2. And if all of the corresponding elements match each other, it's an equal matrix. So here we would say A equals B. Matrix operations. Adding and subtracting matrices is a pretty simple concept. It's just basic arithmetic. So if I'm going to add matrix A plus matrix B, I am literally going to add matrix A and matrix B. I'm going to take the first element in matrix A, which is 8, and to that I'm going to add the first element of matrix B, which is 12. Then I'm going to take the second element in matrix A, which is 3, and I'm going to add to that the second element in matrix B, which is -7. Then -5 is going to be added to 6. And last but not least, 14 plus -23. Now I'm going to combine them, and 8 plus 12 is 20. 3 plus -7 is -4. -5 plus 6 is 1. And 14 plus -23 is -9. And this is your solution. B minus C. If I wanted to do B minus C, well, I can't do it because they don't have the same dimensions. You cannot add or subtract matrices that have different dimensions. So go ahead and try the following. And here is the solution. Scalar multiplication. This is literally distribution. So all you need to do is take the number that is outside of the matrix and multiply it by everything inside. So I'm literally going to do 3 times -6, 3 times -3, 3 times 7, 3 times 10, 3 times 2, and 3 times -15. And my solution is going to look like this. -18, -9, 21, 30, 6, and -45. Go ahead and try the following. And here's your solution. Properties of matrix operations. You've seen all these properties before. The commutative property says that A plus B is equal to B plus A. The associative property says that the quantity of A plus B plus C is equal to A plus the quantity of B plus C. And then the distributive property, the left scalar is K times the quantity of A plus B is equal to KA plus KB. And right scalar is when that scalar multiplication number is on the right side of the quantity. The quantity A plus B times K is equal to KA plus KB. So sometimes we're going to have to do multi-step operations. The following example, I have 2 matrices, P and Q. And I need to find 4 times the quantity of P plus Q. Just like normal, we have to do order of operations first. So I have to do what's inside the parentheses first. So I'm going to do 4 times P plus Q. P plus Q is going to give me 3 plus -4, which is -1. 8 plus 5, which is 13. -2 plus 7, which is, 5. -5 plus -3, which is -2. 5 plus negative 10, which is negative 5, and negative 4 plus negative 6, which is negative 10. And now I can go ahead and distribute that 4, do the scalar multiplication. So 4 times negative 1 is negative 4. 4 times 13 is 52. 4 times 5 is 20. 4 times negative 2 is negative 8. 4 times negative 5 is negative 20. And 4 times negative 10 is negative 40. And that's your solution. Go ahead and try the following. And here's your solution. Almost done. Solving a matrix equation. This is it. We're going to wrap it up here. If you have two matrices of the same dimensions, and then you're given an equation like 4x minus b equals a, and you need to solve for x. You are literally going to solve for x. So I'm going to get this x by itself, so I'm going to add b to both sides. And I'm left with 4x equal to a plus b. And now I'm going to divide both sides by 4. And a plus b over 4 is the same thing as 1/4 times a plus b, and you should be able to identify that. If you're struggling from getting from here to here, just remember that x over 4 is the same thing as, remember there's an imaginary 1 there, 1 over 4 times x over 1. Okay? So, make sure that denominator, grab it and make a fraction out of it. Now I'm literally going to plug in. I'm going to take 1/4 of matrix A plus matrix B. I'm going to add negative 9 and 5, and I get negative 4. 15 and negative 7, and I get 8. 4 and 8, and I get 12. 2 and 14 gives me 16. Negative 10 and 10 gives me 0. And negative 5 and negative 3 give me negative 8. And I'm now going to divide each of these by 4. 1/4 of negative 4 is negative 1. 1/4 of 8 is 2. 1/4 of 12 is 3. 1/4 of 16 is 4. 1/4 of 0 is 0. 1/4 of negative 8 is negative 2. That's my solution. Try this one and we'll be done. And here is your solution. Your in-class assignment for Chapter 0, Section 6 is going to be on page P27, and you are going to need to do numbers 2 through 44 even. See you tomorrow.